Hi guys! In the video today, we're gonna find the first 5 non-zero terms of the power series representation centered at x equals to 0 for the function f of x equals to 2x squared over x minus 6 parentheses squared. We're gonna split this answer in 6 steps. Step 1. Note 1 plus x squared plus plus x to the power n is equals to, I'm going to multiply the top and bottom by 1 minus x. So we're going to have 1 minus x to the power n plus 1 over 1 minus x. So if absolute value of x is less than 1, then the limit when n approaches to positive infinity of the series from k equals to 0 to n of x to the power k is basically the series x to the power k when k is from 0 to plus infinity. And if we compute the limit, we know the limit when n goes to positive infinity of x to the power n plus 1 and n is less than 1, this limit is 0. And then we're basically going to have just 1 over 1 minus x. Step 2, I'm going to remind you guys a theorem. The theorem says, suppose that the power series from n equals to 0 to positive infinity of an times x minus c to the power n has the radius of convergence r, then the power series from n equals to 0 to positive infinity of n times an times x minus c parentheses to the power n minus 1 also has the radius of convergence r. Notice n times an times x minus c to the power n minus 1 is the derivative of the series an times x minus c to the power n that we had before. So cool, my function and my derivative has the same radius of convergence. Let's keep this in mind. Step 3. Since the power series from n equals to 0 to positive infinity of xn is equal to 1 over 1 minus x for absolute value of x less than 1, let's apply the derivative in both sides. So the derivative of the power series is going to be n from 0 to positive infinity of n times x to the power n minus 1. Okay, and what's the derivative of the second one? Yeah, the derivative for the right hand side is definitely 1 over 1 minus x, parentheses squared. And it's going to work for every single x such that the absolute value of x is less than 1 by the theorem that I mentioned before. With that, let's go to step 4. Replace x by x over 6. Before I had the absolute value of x was less than 1. And now I have the absolute value of x over 6 is less than 1. It means the absolute value of x is less than 6. Yeah, I basically multiplying both sides by 6. And replacing inside the equation that we had above, we're going to have the series from 0 to positive infinity of n times x over 6 to the power n minus 1 is going to be equal to 1 over 1 minus x over 6 parentheses squared. And that's going to work for x less than 6, the absolute value of x less than 6. So maybe at this point you're still not sure how we're going to end this. So let's go to step 5. Look, if the series from n equals to 0 to positive infinity of n times x over 6 to the power n minus 1 is going to be equal to 1 over 1 minus x over 6, parentheses squared. That's the same as 1 over 6 minus x, parentheses squared, over 6 squared. And notice 6 minus x, parentheses squared, is the same as x minus 6 parentheses squared. And then it's going to give us, that's going to be equal to 36 over x minus 6 parentheses squared. And then we have the series from n equals to 0 to positive infinity of n times x to the power n minus 1 over 6 to the power n minus 1 is going to be equal to 36 over x minus 6 parentheses squared. That's the same as what is 36? 2 times 18. And then I'm going to write that's going to be equal to 2 times 18 over x minus 6 parentheses squared. Okay, we're getting close to the function. Okay, but we must multiply by x squared and take this 18 out. How are we going to do this? Multiply by x squared over 18 in both sides of the equation. So it gives us the step 6. Since we have this equality, multiplying both sides by x squared over 18 is going to give us my series from 0 to positive infinity of x squared over 18 times n times x to the power n minus 1 over 6 to the power n minus 1. It's equal to 2x squared over x minus 6 parentheses squared. Wow, great. That's my function, and that's going to work for absolute value of x less than 6, as we found before. That basically is my interval from minus 6 to 6. It means my r is 6. And my series is actually from n equals to 0 to positive infinity of n times x to the power n plus 1 over 18 times 6 to the power n minus 1. And then we can find the 5 non-zero terms. Let's plug n is equal to 0. Oh, that's 0, so it doesn't count. Let's continue. N equals to 1. We have 1 times x to the power 2 over 18 times 6 to the power 0, and then that's basically x squared over 18. And then you're going to find the other terms, plugging n equals 2, n is equal to 3, 4, 5, 6. And then we have x cubed over 54, x fourth over the power 216, plus x fifth to the power 972, plus x to the power 6 over 23,328, and that's it. We found the first 5 non-zero terms of the power series representation centered at x equals to 0 of the function. I hope you guys like the video, and make comments, suggestions, subscribe to the channel. Thanks for watching. Bye bye.